Please sit down. Thank you. Excellent. Thank you so much. I was just saying to Ingrid, someday they'll have a Fran-sized podium, which will be a lot shorter than this one. So I'm Fran Berman. I'm co-chair of RDA's council, and on behalf of everyone at RDA, I want to say welcome. This is just a tremendously exciting plenary for us. First of all, we're really delighted to be in Canada. This is our 10th plenary. It's our first plenary in Canada. Canadians have been involved with RDA since the very beginning, since even before the first plenary. It's a thrill to be here, and as a North American, it's really a thrill to be at our neighbors. I got to drive up here, which is something I've never done to a plenary before. So we really appreciate the opportunity to be in Montreal. We're going to hear from our hosts, and we thank them so much for this time. I just wanted to give you a little bit of perspective. How many people were at the first RDA plenary? Fantastic. So as you remember, how many people have been to all the RDA plenaries? Wow. That's amazing. So these are like, you know, the elders of our tribe. The first RDA plenary, we had about 240 people from 30 countries. All of the RDA people were the people that came to the plenary. Today, we have more than 6,000 people in RDA from 130 countries. And it's a tremendously active community. So you see the working groups, the interest groups, the birds of a feather, the adopters, the students, the affiliated organizations, and it's a tremendously exciting activity. This is a really important plenary for us. So 10 is a really good number to start thinking about the next 10. And so from the council side, myself and co-chair Ross Wilkinson from Australia, so Ross has to raise his hand, we've been thinking very hard about what does the next 5 years look like, and we're starting to really think through a strategic planning approach that will sort of help us get going in the near term. So over the next few months, we're going to be thinking hard about what can we do to create more impact in the next 10 plenaries, to make the organization run more efficiently in the next 10 plenaries, to be able to expand our community and our reach in the next 10 plenaries. And so there's a lot of thinking, and we'll be very, very interested in your opinion on this, because this is all of us, it's our community. And you'll see Sandra Collins and others will run a strategy session in the business session later on this week. So please be there and participate. I also want to tell you how excited we are that Ingrid has taken on the Acting Secretary General role. The Secretary General recruitment process just closed. We will have, because unfortunately Ingrid has a day job and will be going back to it, we'll have a new Secretary General early next year. I want to tell you how lucky we are. Ingrid hit the ground running. She's extremely distinguished, strategic. She has a great perspective, and RDA has been running really smoothly on her watch. So we all want to thank Ingrid very much, and I told her I wouldn't make her blush, but I lied. I also want to tell you that council members are here in force and really interested in talking with you about any of your opinions about RDA. I'd like to ask the council members to stand. Ross, you have to stand too. Ross is from Australia. Bernard over there in the dark is from the US. Sandra is from Ireland. Doris is from Germany. Edith is from Belgium now, right? Okay, and then anybody else standing? Okay, and so please find them, ask them anything you like, share your opinions. It's really important to us. Meanwhile, of course, as part of council, we have the OAB co-chairs and the TAB co-chairs, so they should stand as well. Where are they? There you go. So Francoise from France, Andrew from Australia are our tab co-chairs. Where are Kevin and Amy? Kevin's over there in the dark. And Amy, Kevin from the UK, and Amy Nurnberger, who I saw this morning, are our OAB co-chairs, and they're, of course, part of council as well. So, oh my gosh, how did you get up there? Well, if you can figure out how to get up there, you can go sit with Amy, so just letting you know. So really ask any of us, and we're all excited to talk to you. Okay, so without further ado, I want to welcome you to Canada, where we're thrilled to be, and I want to hand it over to Ingrid.
Thank you, Fran, for that. This is really a great opportunity. I am a lucky girl because at Plenary 4 in Amsterdam, I was allowed to speak to all of you, and now in this temporary capacity, I can do it once again. So, welcome everyone to Montreal, and welcome to the plenary meeting of the RDA, the Research Data Alliance. And first of all, a big thank you to our local hosts for inviting us to this beautiful city. And of course, a warm welcome to all of you. And I'm really thrilled to see so many familiar faces. I've been at all the plenaries, so it's really a comforting thought that I see friendly faces in the audience when I stand here. But I also see a lot of new faces, and that's great as well. And I met many of you this morning in the newcomer session. I think we have a very exciting week ahead of us. And I'll mention some elements. We will have a great Canadian keynote this morning, and a wonderful panel as well. We will have plenary sessions that will inform you about the business and about the outputs of RDA. And we have a very impressive number of breakout working sessions organized by the heart of RDA, our working and interest groups. We also have, I think, around 20 birds of a feather sessions this plenary, and I think that is really a record. Sessions organized by people that want to work around new themes, want to start up new groups. And I also have seen that we have one in the area of common services for digital humanities, and that makes my humanity heart jump. And finally, at the end of the week, we will have the Canadian National Data Services Framework Summit, and I think that is a great way to end this week. So together we composed, I think, a very attractive menu with dishes for everyone's taste. And this special menu that we have created together served this plenary extremely well, since this Canadian plenary is a plenary of anniversaries. And first of all, very personally for me, it's a great day because my eldest son turns 21 today. So that is really a big anniversary. But there's more. And now I need to find the clicker. Because this year, Canada celebrates its 150th birthday. In the early 19th century, the North America Act united the 4 British provinces here into the Dominion of Canada. But there is even more. Because the city that we are in is also a birthday girl. It's her 375th birthday. Because in the 17th century there was this small mission post called Ville Marie that became the center of the fur trade and also for French expansion. And this was later recalled Montreal according to the mountain that we have here. So lots of birthdays, but there is one more anniversary to celebrate, and that is the anniversary of our own RDA plenary. Now, of course, one could argue that the RDA plenaries are only a means to an end. One of the instruments in the RDA toolbox to create outputs. But on the other hand, I believe that the plenaries really are the backbone of RDA and of our community, because they provide the physical meeting place for the community, where data practitioners can meet, can exchange ideas, can work together on data sharing issues. So the plenaries for me are very much the embodiment of the neutral forum function of RDA and the beating heart of the organization. And we're not throwing a party tonight in their honor, but I would like to put a little spotlight on the plenaries nevertheless. So let's go through them. We started off in the autumn of 2013 with the launch of RDA in Gothenburg, Sweden. And under the theme Global Partnership, we crossed the ocean to Washington for Plenary 2. And from there, we went off to Europe again. We went to Dublin, and there we talked about the data sharing community. And for Plenary 4, we only needed to cross the channel, and we landed in Amsterdam, where we reaped the fruit of our labor. There, the first outputs of RDA were presented. And we went back across the ocean again to lovely San Diego, and there we talked and I think that came naturally, about the adoption of those first RDA deliverables. The adoption was center stage. Paris then, also a beautiful city. The sixth plenary, and also I think one of the best attended plenaries, with a focus on climate change and on industrial collaboration. And then we made a big jump. We went to Asia for plenary number 7. And in Tokyo, we discussed data sharing in the era of open science. And at Plenary 8, there was another novelty. Plenary 8 was part of the International Data Week that was co-hosted with our affiliate partners CoData and the World Data System, and we held that conference in Denver. And then we're getting close. Only 6 months ago, we met one another in Barcelona, Spain, where the focus was on data infrastructures for open science. And here we are, the 10th plenary of RDA in Montreal, the anniversary plenary. Now, along the course of all of these plenaries, RDA has matured. I think RDA started off as a happy toddler, without a care in the world. But of course, like all kids, we grew older and we started to realize that we were achieving something really here. And we needed to figure out what our role and our place in the world would be. And we continued to build a community, to expand the organization, and to collaborate with other organizations more and more. And here we are now. We have reached adolescence, a period of confusion, a period of transformation. A transformation, in the case of RDA, into an adult professional organization. Here you see a quote by Zbigniew Brzezinski, a former US politician, and he said, "Anniversaries are like birthdays, occasions to celebrate, to think ahead, usually among friends with whom one shares not only the past, but also the future." And I think that we also need to think ahead as RDA. We need to redefine ourselves. We cannot continue to grow without further professionalizing the RDA organization. RDA needs to remain able to grow and to scale, and needs to become sustainable. RDA needs a new strategic roadmap for the future, and this, as you already heard from Fran, is something that is very high on the agenda of Council, and it is also something with which we need the help of the whole community. And I really do believe that within RDA, we are amongst friends. Friends that now share a past of 10 plenaries, but hopefully a bright future as well. So we would like to invite all of you to help us to define this new strategy, because that will be something that we really need to think hard about. And you will hear more about the strategy and also the possibilities to provide input for that in the plenary business session that we have later this week. Then I have a number of housekeeping announcements. The first one concerns the TAB elections. We will open today the elections for new members of the Technical Advisory Board, and we have 9 lovely, brilliant candidates for 4 posts, so you really have something to choose there. There is a poster available that explains a lot, gives you background information, information on the candidates, and also information on the balancing criteria and the process. And this poster you can find in the poster and demo area, which is in the foyer on the 3rd level. There is also a link on the homepage of the RDA website that leads you directly to that page. And you have some time, you don't have to vote today, you have the time until the 3rd of October to do that. 1 p.m. UTC, to be very precise. What I also need to mention that during this plenary, you will see people wearing what we call ribbons, but what are in fact not ribbons at all. So I have mine here. You see people with plates in different colors. And these plates indicate that people are from Secretariat or TAB or the Organizational Advisory Board or Council, also volunteers or sponsors. that is not so important. The important message is that these are people that are willing to answer any question that you might have around RDA, around this plenary, whatever. So I would say take your chance. If you have a question, walk up to people with a plate, a tag like that, and pose your question. Then I would like to tell you that we have this area for posters and demos in the foyer on the 3rd floor. And I would like to invite all of you to be there at 11 because it will be officially opened by one of the council members, Edith Wertlich. And make sure to come back tomorrow because these posters are rotating. So if you only come once, you will miss half of it. So please, and they will be there at any break. So please look at that. Then I need to tell you that if you want to tweet, and we very much hope that you will do so about the plenary, please use hashtag RDA plenary. There is also a hashtag RDA10, but for continuation purposes, we would very much like to ask you to use hashtag RDA plenary, although it is a bit longer. And I think I have given you all the housekeeping stuff with that. The only thing I would like to say from my part is that I wish you a very exciting and fruitful 10th plenary. And then I completely, immediately move over because with this I would like to hand over to our local hosts, starting with Madame Marie-Josée Hébert, vice-rectrice à la recherche, à la découverte, à la création et à l'innovation. And I guess that translates into Vice President Research at Montreal University, where she is a full professor at the Department of Medicine. Thank you very much.
Merci beaucoup. Bonjour à tous. C'est un grand plaisir de vous accueillir à Montréal. Good morning, everyone. It is an honor, a privilege to welcome you in Montreal and to host the Research Data Alliance 10th plenary meeting in Montreal on the territory of Hochelaga, Tiohtià:ke, the traditional Mohawk settlement previously established on the island of Montreal. And this island has been a traditional indigenous land for more than 1,000 years, and we need to remember that. The Université de Montréal would like to acknowledge the role of First Nations and the story of our great city. I said it was an honor. It is a privilege, indeed, to host this meeting, but it is also, I believe, very exciting. As you may know, Montreal is currently experiencing an incredible intellectual scientific development in the field of artificial intelligence, big data information technologies. Some of you may have seen some of the symposia yesterday organized by Ivado, our platform, Érudit. You will hear this morning from one of the keynote speaker, Yoshua Benjo, is the scientific director of the Montreal Artificial Intelligence Institute, MILA. And the development represents, these developments overall represents hundreds of millions of dollars invested in data-driven academic research, implementation of technological hubs, and specialized employment. But being a central actor of this structural change taking place in our city and scientific community, Université de Montréal wants to extend its leadership by supporting RDA's mission here in Canada and in the rest of the world. The organization of the 10th edition of RDA plenary meeting is a concrete demonstration of our commitment. We want to contribute actively to the sharing and the opening of access to research data. And like all of you in this room, we are fully aware of the numerous issues related to data management, the challenges, but also the opportunities. We all know how inefficient data structures affect collaborating amongst data producers and users. Moreover, I strongly believe that we would not only consider sharing data for research, but also sharing research data that are emerging from current research. And we need to find ways to value research not only for its results and publications, but also for its capacity to change the world, because this is really what it is all about. Open scientific research is the best means, I guess, of changing the world, because it promotes values such as common good, social justice, responsibility, diversity, ethics, and the dissemination of accessible knowledge. In that sense, data certainly influence our practices, but they also influence everyone's lives. And sharing research data is at the core of many issues and debates, not only for the scientific community, but for the society as a whole. So we have a responsibility, and we have the responsibility to fulfill two tasks: make research data accessible and ensure their proper management. And only by doing so will we meet the conditions to ensure validity and reproducibility of results, and to enforce the role of research institutions as social actors. This is not by no means an easy task. Change is always challenging, uncomfortable. Not all disciplines or sectors are equal when facing these ongoing transformations. Why is it important to us? Why is it important to Université de Montréal? Because the pressure to our researchers to produce, share, and analyze a dramatically growing amount of data is greater than ever. At the same time, technological innovations increase the need for data as decision-making tools. And considering the current situation, we at the Université de Montréal have started undertaking comprehensive reflection on research data management. Last January, we created a new office, the Office for the Responsible Conduct of Research, and within this office, we are now adopting a position in support of our scientific community. Instead of imposing regulations, we really want to support the choice of our researchers towards open research and open access to research data. We are aware, like you at RDA, of the need to teach good data sharing practices as a basic part of the curriculum. And we are also working on a strategic plan on data quality and integrity in order to offer a better service to the community. And this is why RDA is so important. It's important to us, but I guess it's important to all of us in the room. And as was mentioned, with more than 6,000 members across 130 countries, RDA is truly providing an extremely valuable and much-needed expertise to both research institutions, governments, industry, and all decision-making actors. Your outputs and recommendations help to operate the much-needed structural transformations that we must meet. Your work is also remarkable because your contribution to RDA is voluntarily. And I would like to thank you all and to congratulate you for your dedication. During the next days, more than 400 members of your network will meet to draft standards, specifications, practices, and policy recommendations, which will all enable data sharing in various fields. You will find solutions that could potentially accelerate interactivity, interconnectivity, and innovation among all disciplines and industries worldwide. So the theme of this plenary session, Better Data for Better Decisions, has not been chosen accidentally. It is our statement. At Université de Montréal, we want to be proactive in the promotion of RDA outputs at the different levels. And we want to give an impulse so that your recommendations lead to concrete policy adoptions and implementations. We brought together in these rooms policy officers, publishers, university representatives, and many more practitioners. And thanks to the different activities organized and co-located in social events, because those are important, we hope to generate conversations and networking opportunities that will lead to concrete realizations. This impulse will not stop its momentum at the end of this week. At least we hope that it will be a sustained, ongoing opportunity, and that we will continue to promote RDA's outputs and take actions. and take action in our institutions, in Canada, and hopefully around the world. We will continue to encourage open access to scientific productions and the valorization of transparent, quality, and reproducible data sets produced by researchers in order to make universities not only better research institutions, but also stronger social actors. So I would like to thank RDA Council and the Secretariat for giving Université de Montréal this great opportunity. I would also like to thank our organizers, members from RDA Secretariat, my colleagues from Université de Montréal, Mark Leggett from Research Data Canada, who provides research data management's institutional network, leverage and expertise at the Canadian level. We also had the logistic support of the Centre interuniversitaire de recherche sur la science et la technologie, located at Université du Québec à Montréal. Thanks to all of you. Merci, merci à tous. Finally, I would like to thank our generous sponsors and institutional partners for your support. Alors, un merci tout spécial à Springer Nature, Social Sciences and Humanities Research Council of Canada, National Sciences and Engineering Research Council of Canada, CIHR, Canadian Institutes of Health Research, Canada Foundation for Innovation, Tourisme Montréal, les Fonds de la Recherche du Québec, Globe and Opal Data for Agricultural and Nutrition. A long list, but it's important to, I guess, thank them all research libraries of Canada, Facets, Open Access Science Journal, l'Institut de valorisation des données, IVADO, le Centre interuniversitaire de recherche sur la science et la technologie, la plateforme Érudit, le laboratoire de cyberjustice de Montréal. Et donc, au nom de l'Université de Montréal, je vous souhaite à tous un excellent congrès. Merci. Merci à tous d'être ici avec nous à Montréal. In the name of the University of Montreal, I wish you a fruitful plenary meeting, productive and interesting workshops, great exchanges with old and new colleagues. And let's not forget it's a wonderful stay here in Montreal, so have fun, enjoy, and thank you very, very much.
So now I would like to give the floor to Mark Leggett, Executive Director of Research Data Canada.
Thanks, Ingrid. Thank you, Marie-Josée, and welcome to Montreal. I'm going to reflect my Canadian roots and issue an apology first. Last night at the social, I highlighted that there was a very fine Cuban restaurant near this venue, and I discovered after the social when I went to a different restaurant that it was closed. So how many people here went to go to Le Habanero? Anybody? Well, that's too bad, because I was going to offer to buy a drink tonight. Okay. Okay, there's a couple people, just remember they did go. Clicker. So I have three things and then some housekeeping that I want to do very quickly. So one is just to highlight, like all of you and the organizations you work for, Research Data Canada has a vision, in our case, to make sure that Canadians have access to publicly funded research, and that it is accessible, obviously, in the international context as well, hence our involvement with RDA. And we do that by working with our stakeholders, which I simply describe as any organization that gives out public funds, like our public funding sponsors here, any organization that receives and does research with public funds, and any organization that supports those two. So it's a very broad stakeholder community, but it's a very great opportunity for me to work with that group. And one of the members of that stakeholder community is the organization that funds Research Data Canada, which is Canary. And I wanted to take this opportunity to let my Canadian colleagues, but also the international colleagues gathered here, that we are launching our first call for innovation in data management, hopefully early in 2018. It's a small amount of funding, but I wanted to mention it here because I'm hoping that you and your colleagues will partner with your international colleagues here at RDA and elsewhere so that we can leverage some of the great projects that have been developed out there and are kind of pushing the boundaries, whether it be projects like SHARE in the US or the Fair Sharing project, which also has its roots in work at RDA. So I just wanted to mention that as something that Research Data Canada is looking forward to, working with colleagues, and we worked closely with groups like the Carl Portage and others in Canada to try and define what the priorities for that might look like. Second, I also want to give you a sense of who's gathered. Usually when I do a presentation like this, I go around and ask who's from where, but that would take way too much time, and we have a plenary speaker that we wish to hear from. But I can say that we have just over 430 participants at this week's plenary from 30 countries, and you can get a sense of the breakdown. Clearly, as is the trend with RDA plenaries, there's a good representation from, in this case, particularly the US and Canada, but also very strong member representation from Europe and elsewhere. Also, a pretty strong gender breakdown, getting close to the 50-50 mark, yes. So that's very, very pleased to see that. It's a diverse community also in terms of the representation of the sectors and domains that everyone is from. A fairly good swath of you are from academic context or the research context, but also a pretty good representation from public agencies, government agencies. So that's great to see, and thanks to Timea and the team at the Secretariat for providing me with that. I also, thirdly, wanted to thank, and again, it's always difficult to put names on a slide, and I noticed here I have Fran, and I'm going to say that I didn't finish Fran's name because I was also going to put Ross's name in there, but this was put in there this morning, so I apologize for leaving people out, but I did want to list the co-chairs there, as well as the members of the RDA Secretariat and RDA US that have been helping us. And again, a shout out to Timea, who's been doing a lot of work. Also, Yolanda and Lynn have been great in terms of the calls that we've been on, and Fran and Ingrid as well in planning the plenary and making sure that it moves forward smoothly. So a big thanks to the RDA team. Also wanted to list a few of the names for people that you hopefully will encounter by name while you're here. I can say, as I did last night, that I've done very little to facilitate the planning here in Montreal. Aubert Landry has been very involved with the team that you see there, with Martine and Chloe and Amélie and others who are here. I also wanted to give a shout out to the University of Montreal students who are at the registration booth and wearing the blue shirts, advertising their home institution. They've been great. I had a chance to chat with a couple of them. So it's really nice to see that involvement from future data scientists from the University of Montreal. And then finally, before a couple of housekeeping, I did want to thank all of you, the plenary participants. As we see the news of another, in this case, Hurricane Maria, barreling down on the Caribbean and turning into a Category 5 hurricane this week. I think today it's supposed to hit landfall. So I just wanted to use that and other contexts that we're well aware of to highlight how important the work that all of you do is. Because without that data, we can't do our best to try and understand the nature of these storms and things like the Zika virus and all those things that you and your colleagues work on. So thanks for being here and having the passion and interest to carry on that work and ensure that data does inform our policy and the things that we do. Finally, just a couple of housekeeping duties, I encountered a couple of hungry people this morning who were looking for breakfast. So coffee is on the 3rd floor. Breakfast this morning was also, hopefully you managed to find it, on the 3rd floor. It's a little confusing at first in the centre because of the layers, but I think you'll very quickly get used to it, especially if you know that the food is almost always at the top. So there's a reason why we put it up there. So the coffee break today is on the 3rd floor. Lunch today and every day is on the 4th floor. It's also the opportunity when you're at coffee breaks to take in the exhibits and the demos and the posters. I think this was maybe a record. I forget where Timea went. A record for the number of posters at this RDA. There were 60-some? Around 50. So that's great. So please make sure that you take the opportunity to take a look at the posters. There's always a lot of time and effort that goes into those. Lunch is seated serving, so it's not a buffet. So if I were you, I would probably make my way up there fairly quickly after when the dinner bell or lunch bell rings. So you will be seated, just find yourself a seat and you will be served. And it is an hour, so, and if you have special dietary requirements that you indicated when you registered, have your ticket from your badge ensemble ready, because that will be presented to the server so that they serve you the right meal. And then this evening we have a social like we did last night, again on the 3rd floor. So there'll be drinks and nibbles, and afterwards you can, while you're having a drink, and those 2 people that put their hand up, make sure you find me and I'll make sure to buy a drink before you go to the Cuban restaurant. There will also be some food for the soul. Montreal is Canada's musical city, I like to say, so there will be some music at the event tonight as well. And finally, just again, a warm welcome to Montreal. My wife, Trina, and I, like Fran, drove to the event. Unlike Fran, it took us 3 times that length of time. I think Fran was 4 hours. We live in Prince Edward Island on the East Coast, so it took us 12 hours. But we do that drive actually quite frequently because Montreal is our #1. We're going to take a long weekend and drive to Montreal and relax for a couple of days. So I hope you do the same when you're not in working sessions and working groups. And if you do have any questions or anything you need while you're here, just let me know, or all of the people that we highlighted earlier. Thank you.
Thank you very much, Mark. So now it's time for the keynote, the one and only keynote of this plenary. And our speaker today is Joshua Benjo. He is a full professor at the Department of Computer Science and Operations Research at the University of Montreal. And he's also the head of the Montreal Institute for Learning Algorithms. And I am personally very excited that Joshua is here today, and I will tell you why. Robert Dijkgraaf, the former president of the Royal Academy of Arts and Sciences in the Netherlands and now the director of the Institute for Advanced Study in Princeton, presents at the moment a series on Dutch television called Minds of the Universe. And in this series, top researchers from around the world present their view on the future, crossing the boundaries of their scientific domains. And one of these top researchers happens to be Joshua Benjo. Joshua studies the workings of the human brain and aims to make computers smarter by using that knowledge. And in an interview that I read with the director of that series, he says that he really admired Joshua. And not only for his scientific achievements, but even more for his, and now I quote, mischievous look as a little boy, because it clearly shows that for him science is fun. So Joshua, please come up. Thank you.
Is there a control? All right. Thank you very much for the introduction. Unusual one. And thank you for inviting me, and thank you for listening this morning. So I'm going to tell you about something that is happening that has very much to do with data, and it's a little revolution in the world of artificial intelligence that came with work on what we call deep learning that really started a little bit more than a decade ago. I wrote a book, if you want to learn more about this from a technical point of view. It's called Deep Learning. It's printed by MIT Press, and there's also a free online version that I negotiated with MIT Press, so people could access the content without paying. Yet the book is selling like crazy for some reason. All right. You may have heard about self-driving cars, autonomous vehicles. I think there's still a lot to improve in that respect. You may also have heard about, or actually interacted with your phone speaking back to you. Again, there's been pretty amazing progress with respect to understanding language and generating language, but yet another area where there's much more research to do. You may have heard about computers playing better than humans, better than the best humans at the game of Go. There was a really surprising event about a year and a half ago where the Go champion was beaten by DeepMind's deep reinforcement learning system. So these are just the signs of something changing in a very significant way. People call this a new industrial revolution, which, unlike the previous ones, is really going to expand humans' cognitive power, not just the mechanical power that we used to benefit from with the previous industrial revolutions. It's probably going to have a huge impact on economic growth in the next decade or two, and it's going to touch every sector of the economy. And what's behind these things that I've been telling you about are scientific advances that started about a decade ago at a time when the very topic of neural networks, because this is what this is about, was really unpopular, but now sort of crazy popular. So that's why I'm here. And it started with work that was done mostly here in Canada, collaboration between three groups, one in Toronto with Jeff Hinton, one in New York, Yann Lequin, and my group in Montreal. And for the first time, we were able to train these deep neural nets, which means that they have more than one or two or three layers. In fact, now they have dozens. And whereas previously people had tried and failed to do that, we had our first breakthroughs around that time. But it took several years before the consequences of that came to fruition, as you'll see some more examples this morning. But before I go there, let me try to explain a few basic things about artificial intelligence. So if we want to build machines that are going to be intelligent, they are going to need knowledge, because knowledge is really at the heart of intelligence. This is, of course, nothing new, but the problem is, how do we put knowledge into computers? And the traditional way of doing this for many decades, the standard approach in AI, has been to try to take the knowledge that we have and can communicate verbally in English, say, or in equations, or through a program that we write, to try to give that knowledge to computers. But that program failed. And there are a number of reasons why it failed, but probably the most important one is that a lot of the things we know are not things we can communicate easily. A lot of the things we know are intuitive, things that I can recognize, for example, in half a second, but I can't explain why I'm able to take that decision or do that recognition. So for decades, we tried to pick the brains of experts. This was called expert systems. And it didn't work. So what is working right now, and what is really causing this revolution, is that we found ways to give to computers a lot of knowledge, not through directly specifying that knowledge, the traditional computer science way of programming computers, but by allowing computers to learn that knowledge by themselves, to learn from data, to learn from experience, to learn from examples. Typically, and this is what you'll find in many applications, the learning will be by imitation. So for example, we look at how humans would solve a problem, and the computer will take many, many examples, maybe millions or even tens or hundreds of millions of such examples to learn to imitate humans performing a particular task. So that's the heart of what machine learning is about. Machine learning started as one of the areas of research in artificial intelligence research, focused on how to allow computers to learn. Now it has become almost synonymous with AI, because pretty much all of the successes we're seeing today in AI are due to computers learning from data. And inside the research area of machine learning is deep learning. This is the area that I've contributed to the most. And as was said in the introduction, is an approach inspired by what we know of the brain. Of course, so this idea of looking at how brains compute and how brains learn in order to build intelligent machine has been around for almost the same time as artificial intelligence has been around, since the 40s. But again, it's only recently that this approach, called also neural networks, really had a remarkable success. I'll try to explain the idea behind deep learning and why we use that name. But essentially, this ability of having multiple levels of representation is at the heart of it. And these different levels of representation, corresponding to different layers in a neural net, correspond also to different levels of abstraction. And by having deeper network, we're able to train machines that do a better job of understanding slightly higher level abstractions than what we were able to before. We still are very far from the kind of abstract thinking that humans are able to do. So as a cartoon of the evolution of AI systems into deep learning, here what we're seeing is, on the left, the classical systems where we would handcraft, hand design a program that go directly from inputs to outputs using a set of rules or procedures that an expert would provide. Then came more classical machine learning, which really became important in the 80s and 90s, where we ask an expert to design features, so transformations of the raw data. For example, if we're doing computer vision, as I'll talk a lot about that, we would think about the problem of vision and what functions of the pixels, because the pixels are the raw data, can we compute that would help, say, a machine discover whether there's a face in the picture or whose face it is. So for example, you might think, oh, maybe I should design a feature that detects the presence of eyes, or that finds where that there's a mouth somewhere. Right? So it's by thinking about the problem a lot and designing specialized features that people were building those systems, and then using machine learning to transform those features into a decision, usually using a linear classifier. Then came the idea of representation learning. This is also fairly old, from the 80s, mostly the work of Rumelhart and Hinton, where instead of designing those features, those data pre-processing by hand, we're asking the computer to figure out, to learn those features, to learn a new representation of the data, because those features are just a new way to represent the data. And so by doing that, we are able to learn more complex functions and aspects of the data which maybe the humans haven't thought about when they hand design those features. And deep learning is just a continuation of that, where instead of having one level of features, we're going to have features on top of features on top of features. So simple features like edges in an image are going to be the basis for building for learning and more complex features, maybe parts of objects, and then those would be combined at a higher level to form more complex features and eventually whatever the task is you care about. So to keep things simple, I'm going to talk about supervised learning, which is the most commonly used form of machine learning, where we are training a computer to map an input to an output, and here we would like the computer to say what is the emotion in the face that is presented as the input image. So for example, we'd like the computer to say for the left image that the emotion is surprise, and the middle one, we'd like the computer to say joy, and so on. So the computer learns a mapping from inputs, here pixels, to categories or to probabilities of different categories. In the case of the neural network, the input pixels will be transformed in a series of computation where at each level we'll have a bunch of numbers corresponding to a representation of the original image in a new space, which hopefully gets you closer to the answer, extracts higher level characteristic of the input. But these characteristics, those features, are not going to be designed by hand. They're learned. And how they're learned? Well, the general idea is fairly simple. We let the network process an example, an image, for example, and it produces an answer. And then we quantify how good that answer is. And then we compute derivatives. In other words, we try to estimate how to change the parameters of the network so that next time the same image would be presented, the answer would be slightly better, just slightly, little bit. But we're going to be doing this with millions of images, one after the other, and after hours or days of training, the system actually learns to do something useful. So, as you see, intelligence here is completely derived from data. There's a little bit of engineering to set up the architecture of those networks, and some notions about the problem we're trying to solve come in, but the vast majority of the information that are put in the system come from data. And so all of these AI applications that are springing around in society right now are all relying on the presence of data that's going to teach the machine about a particular problem that we want the machine to solve. So if you're one of those many people who want to use AI to solve a problem, the first question you have to ask yourself is, well, if I want to solve this particular problem, what data do I have to teach the machine about what I want it to do? And is it data that is currently available, or is it data that I will need to collect? How much is it going to cost me to collect that data? And sometimes you may have the data. For example, I might have medical images, but that's just the input part. I also need to tell the computer what it should do for each of these images, maybe to identify the pixels where there's a cancer cell. So that's called labeling, and that might be costly. So you have to really be careful about not just, oh, I have some data, but how much of it do you have, and is it what I need to train a machine to perform a particular task? So, as I mentioned, after our initial breakthroughs that were conceptual and tested on toy data, it took a few years until we started getting really impressive improvements with deep learning on a variety of major industrial tasks. It started with speech recognition, so that by 2012, if you had an Android phone, you had already on your phone speech recognition using neural nets. For the most part, it's done through a server, but nowadays phones are getting more powerful, so if you're disconnected from the internet, there'll still be a sort of a lower grade version of the neural net running on your phone. So what happened when you see in the figure is that for about a decade, the error rates on some benchmarks in speech recognition really were flat until that technology was introduced and created a big stir in this field. So in the last few years, basically all the old techniques that existed before have been put aside in favor of systems based on neural nets. And something similar happened in the area of computer vision. So computers can now look at an image and identify the main objects in it. The main data set that has been used for these systems has about 1,000 object categories, but now companies are building systems that can recognize even much larger sets of categories. This technology has also been used, for example, by Facebook to recognize faces. So when you tag somebody's face on a Facebook post, you're giving information to Facebook that will help it train a system that can distinguish between millions of faces of millions of people's faces. The performance on these systems is there. Oh, sorry. The performance on these systems improved gradually from about 2012 to now, but around 2015, for the first time, at least quantitatively, we reached human-level performance on a particular task. Now, I still think that computers are much worse than humans at interpreting images, and they will make very stupid mistakes that humans will not make, whereas humans will make mistakes simply because they don't know about a particular category, which is expected. So now in the last couple of years, we're starting to see applications of this. So it's not just a fun game to recognize the content of images, but this is being used in numerous applications. I mentioned Facebook, but Google also has applications that uses recognition of content of images. It's now going into the big industry, but it's also going into healthcare applications. And an example that I've been involved in is recognizing cancer cells in medical images. And in particular, there's a Montreal company, Imagia, that has developed a system that can recognize colon polyp cells better than the best doctors. And that's pretty important. And we're seeing more and more of these kinds of things where because simply the computer can be trained on a number of images and cases much more than any doctor would have time to look at, it can become really an expert on this. But keep in mind that the doctor can do many more things that this system can do, right? This system can only recognize these particular cancer cells on a particular type of device. So we are very far from AI, human-level AI, but still, this is an example to illustrate how this can be useful in society in many different places. Another example I want to mention is machine translation. This is something that we also worked on in my lab, starting from around 1999 with the idea of representing the semantics in words using a neural net and these representations I mentioned earlier, to more recently breakthrough in machine translation, which ended up in the last few months with Google adopting this kind of system. And so now if you're using Google Translate, it's really using these deep learning systems, and the improvement in the quality of the translations has been really amazing. So on the figure you see on the x-axis, human evaluation of translations, and n-gram translation is, the systems that existed before they used those deep nets, and we see that we've more than half the way between the existing systems, previous systems, and human-level quality of translation using those neural nets. Another area where there's a lot of expectations and a huge amount of applications is human-computer dialogue. So we are seeing a lot of research, a lot of investment in developing the same kind of technology that allows computer to understand, to some extent, a sentence to be translated and then can generate a translation, this time to understand some context of a dialogue and then generate the next utterance in the dialogue in order to achieve something, or just for fun, right? These are called chatbots. Let me mention a few interesting things about how these deep nets can handle data and play with their representations. So one nice example is that it's very easy with those models to combine different types of data, something that wasn't necessarily obvious with classical statistics. So what you see in the figure is that we have these two modalities, and we have two pipelines of sequence of transformations and representations for each of the modalities, and then once they have been put in the right space, they can be concatenated or combined or aggregated into a pipeline that will produce eventually the answer. So we can easily put in several types of data, and we can even fairly easily handle missing data. So maybe some of the modalities are present. For example, maybe for a particular patient, I have some measurements, but I don't have other types of measurements that other patients could have, and it's fairly easy to handle these kinds of missing data with deep learning. Another nice example which illustrates both the application and the ideas behind is what has been achieved by Google in their image search system, by the way, which was set up by my brother Sami, who's a researcher at Google. What they're doing is they're training two networks. So again, we have these two modalities, but one is text and the other is image. And they're learning a sort of mini neural net, which maps, one maps the image to 100 numbers. So this is a sort of shared representation. And the other network maps a query that you type in image search into the same space. So you can transform data that is in one form into a new form, and the new form could be something that it invents to achieve an objective. Here the objective is that the images and the queries that should be related to each other, because for example, when you're shown, when you type dolphin and then you're shown this image and you click on the image, that means probably that it's related. In that new space, the two vectors corresponding to these two modalities would get close to each other, would be near each other, so we could use this, for example, for retrieving images that are connected to a particular word, or vice versa, to actually find words or queries that correspond to a particular image. So you can learn to transform from one space to another, and you can learn to transform from a data space to a new space that is completely learned, that is created by the machine to make those tasks easier. And then you can learn to relate those high-level representations, for example, of images or text or sounds or other things, to each other in these more abstract spaces that are being discovered by the computer. Let's see, can somebody start the video for this? Yeah, just go somewhere in the middle of the video because I won't have time to go through all of it. So this is just illustrating that this technology, go to the middle or the end, is now being developed also for robotics. So it used to be that robots were programmed to do a very prototypical movement, always the same movement at always the same place. And now we have different kinds of robots that can understand the content of images because of all of these advances, and that can also learn to control objects, to pick up objects, even objects that they have never seen before. Can you go further? Yeah, that's good. Even further? Yeah, so good. That's what I wanted. So they can, pick objects in a mess of objects, and I guess there's a lot of industrial types looking forward to this kind of robots in more messy environments than the usual industrial ones. I mentioned supervised learning, but in the last few years, again, with contributions from my group in Montreal, there has been advances in the ability of computers to learn from unlabeled data, from just observing the data and capturing the distribution. So let me show you some examples of how these systems are being used. So these are called deep generative models. They can generate things like images, sounds, text. They can fill in missing data. They can generate from ab initio, or they can transform one thing into another thing, like going from speech to text or from image to image. In the example that we see in the bottom, what they're doing is what's called super resolution. So you start from the image on the I guess we don't see the original here, but you see the classical system on the left, bicubic interpolation, is trying to recover the missing pixels to get a higher resolution. And where we're seeing in the middle are the outputs of these networks, which invent the missing pixels in a way that retains sort of a crispness that you didn't get with the classical systems. So basically, those systems can synthesize, generate in a way that's actually random, plausible missing information here, the details that were missing in the low resolution image. They can do things like take a sentence like the bird is short and stubby with yellow on its body and synthesize an image that would correspond to that. Or they could take an image like in the bottom left that's in gray and invent colors that make sense for that image. Of course, they've been trained to do that, but keep in mind that they have never seen, of course, this particular image. They can do things like, given a drawing of a building, make up actually the image of the building. Or given a drawing of a bag, like in the bottom right, actually make up the image of a bag that would correspond to the drawing. They've also been used for artistic effects. So for example, given an image on the left, these systems are trained to transform the image so that it will look in style like, say, a particular picture of Monet or Van Gogh or Cézanne or ukiyo-e. Yeah, this is quite impressive and can be a lot of fun as well. Just a few words before I'm going to let you answer questions. First thing is, all of this may look very impressive, but we're really far from human-level AI. And there are lots of clues for that in the kinds of errors they make or how they can be fooled. So what you see in the image is a system that's meant to recognize the content of images, and on the image on the left it says dog, as it should, but if you tweak the pixels in a particular way, a particular recipe, you can sort of induce the system into thinking that this is an image of an ostrich. So the pixels have only been changed a little bit and you don't even see it, but it now thinks it's completely the wrong category. Of course, well, we think that humans wouldn't make those mistakes, but it's hard to replicate the experiments with humans. The other important thing to keep in mind is that although we're far from human-level AI, even if we stopped the research right now and we just did engineering and building products out of this, there would be at least 10 years worth of reaping the benefits of the kinds of things I've shown you in many, many applications. Another related topic is a lot of economists have been starting to consider how this will change our society. And of course, this is very likely to bring a lot of automation in many areas, in many sectors, and they've tried to calculate like how many billions or trillions in different sectors this is going to have in terms of impact. But in terms of jobs, the different economists don't agree, but roughly half of the jobs will be impacted. Doesn't mean that people will lose their job, but a part of the work they were doing is going to get automated thanks to this and other technologies. So I think this is something to keep in mind as we look forward. For people in industry, I think embracing the changes that are coming with these technologies is not just about competitivity, it's really a question of survival. And right now there are many CEOs around the world that are looking at all this and feeling very concerned. What should I do in order to remain in business over the next decade? Let me say a few words about Montreal. So something really special happened here, and I would say the most important reason for Montreal now becoming a hub in AI is simply that we have this critical mass of talent that has developed slowly over the last decade. And we've worked together, putting together the strongest people in the field in one big group, which has over 200 researchers focusing on deep learning and reinforcement learning, which is attracting a huge amount of visibility around the world, both because of its fundamental research outputs, some of the things I mentioned briefly, but also because industry is now coming to Montreal to open research labs in AI, and governments have been investing massively in this area. Montreal is becoming a sort of example for other cities around the world in terms of innovation and science working together. So let me close with the questions I think that may be closer to your interests regarding the data and ethical issues. As I said, data is at the heart of the new economy that's coming based on AI. And so the question of, where's that data coming from? Who owns it? What, should we allow to do or not do with that data are really, really important. Right now, for example, if we had patients not share their data, then all of these goodies and improvements in medical treatments that may come from AI will not happen. So it's really important that we find ways to balance, on one hand, the privacy and the social value of sharing the data. We want to have laws that make the consumers or the patients feel that the data is not going to be used against them, for example, by insurance companies. And for this, I think governments are really important because they can set up institutions, organizations that people will trust, and they will guarantee that the data will be used for beneficial use and will bring social value to all of us. One idea that has been proposed by one of my colleagues a couple of years ago is to have third-party organizations, not even governments, but just independent organizations, maybe regulated by governments, that would act as data trusts in the same way that we have financial trusts. In other words, organizations that would essentially have a contract between users or owners of the data, and then to make sure that they will take care of all the legal aspects. They will make sure that the users of the data, the companies or the organizations or the researchers using the data will respect a certain number of principles. Because of course the individual user has no means of doing that, right? So we need to also put together that responsibility in the hands of trusted neutral parties. The last element I want to bring is that scientists in AI are meeting a lot over the last year. I've been in many, many meetings, really about the issue of the responsible use and development of AI. So for example, AI could be used for good and for bad. One example that is right now in front of the UN is should we have international treaties to ban the use of AI for lethal autonomous weapons? In other words, weapons that can kill somebody without having a human in the loop. Is that something morally acceptable? You might not realize it, but landmines, which have been banned essentially to all practical purposes, are lethal autonomous weapons, but they are stupid lethal autonomous weapons. And now we're going to have smarter killer robots. I don't think this is something we want. Another example is that this technology could be used by, for example, authoritarian governments or even our governments in a sort of big brother way to watch over everyone and monitor where you're going and what you're doing. And of course, we have to be wary of these kinds of things. Finally, my last line. As I mentioned, there'll be very likely serious disruptions to job markets because of the automation and accelerated automation brought by AI. And so on one hand, there's going to be some subset of the population suffering from those changes. On the other hand, this is going to create a huge amount of wealth. And well, you know, wealth is nice, but it might also mean concentration of power that goes with it. And I believe this is something, again, to be wary about, because usually that doesn't rhyme well with democracy. So I'm going to stop on this, and thank you very much.
Does this work? Yes, now it does. So thank you very much for this marvelous talk. And I think you've shown us some mind-dazzling developments, I might say, in the area of deep learning and artificial intelligence. And I think we have time for 1 or 2 questions to take from the floor. So if there's anyone who would like to ask a question, please come forward and walk to the microphone. Anyone? Yes, Rainer, please go ahead. Oh, there's someone on the phone with a question.
Let's try this one. Thank you very much for this exciting talk. We're just wondering, are there existing data standards or upcoming data standards? I think we have a lot of people also in this room who try to apply machine learning algorithms and this kind of stuff. And the input data are normally feature vectors, one-dimensional signals, two-dimensional signals, images, and so on, and their corresponding class. Is there any what we do normally currently, if we want to input our data, the most work goes into the adaptation of the data so that it can be understood by the system who process the machine learning, TensorFlow, SIS, MATLAB, or whatever it is. Is there any upcoming standard how the data will be presented, or a consensus how to do that, so that we have a certain kind of interoperability between these systems?
Well, if you look at any of the packages that are popular for deep learning, like you mentioned TensorFlow or PyTorch, those packages will be able to read from a large number of common file standards. It's not really a big issue. One way to think about it is, it could be flat files like database records, it could be images, it could be signals, and usually these packages can manage all of these things. So I don't think that you need a standard for this, although it might be good to consider how these different packages interoperate. I haven't looked at that, but that's an interesting question. But it's not a big deal to do file conversion. So these systems are usually programmed, for example, in Python, and Python offers all kinds of facilities to transfer things from one format to another.
Okay, thanks.
Other questions?
Hi. In your talk, you mentioned at one point about sort of the rights of users and how oftentimes the data that originates from customers or users, they've lost sort of control over it once it's in the hands of...
Right.
And so maybe with the recent Equifax hack in mind, and with recent developments like blockchain, is that status quo going to be possible to maintain, considering that data security is like really, there doesn't seem to be any possibility of data being securely stored like with full certainty. So how can that remain the status quo with these kinds of events?
Right. I don't have the answer to that question, but I think it's an important one. In particular, if we want the buy-in of those people or organizations that are providing the raw data, we need to find better ways of securing it. So in principle, you could encrypt it, and there are techniques for encryption, but of course, if the keys themselves are being discovered, then yeah, you're also lost. I think a lot of the mistakes we have are simply because organizations that are handling the data are not taking the security aspect seriously enough. It's not that you need necessarily super complicated technology to make it more secure. So it's just not being done properly. So again, I think this is a place where some form of government regulation to guarantee a certain level of security would be potentially helpful.
So, thank you for answering these questions. I want to extend Rainer's question about standards for data inputs to the labeling part.
Okay.
You see many of us here are worrying about metadata schema or standards actually for metadata schemas and ontologies and so on.
Right.
What do you think about that?
Yeah, I think it's really important. I mean, it's not, maybe I should come back to my previous answer. It's not about the data format. In terms of representation, it's about consistency between different data sets. So a good example I've seen recently is the GEO data set, which is a medical data set collected in the US. And it's actually a collection of thousands of data sets coming from different studies. The problem is that each study is using a different way of doing things. So if you were only to look at a couple of studies, there's no problem at all, right? It's not that the data is in a weird format. It's that those different mini data sets haven't been harmonized in terms of how to name things and just a simple thing is how to name things. So ontologies obviously could be an important tool for that. And maybe when we're thinking about data sharing, you shouldn't just force people to share their data, but also force them to, if possible, fall into existing naming of things, ontologies, and so on, so that it becomes easier to aggregate data from different sources. And for example, in the GEO case, because those data sets are so disparate in the ways that they're naming things, it's very difficult for AI to be applied, even though it's a huge resource. It's just like now it would be a huge amount of work to reconcile all of those data sets.
Thank you.
I'm going to be strict. One more quick question with a quick answer, because otherwise we will not have enough time for our panel. So please go ahead.
I hope it will be a quick answer. We will see. It will be a quick question. So, thanks a lot for your presentation. It's really inspiring. There is another issue about, ethical issue around all this kind of technology, machine learning, which is many of these systems which are built are actually used not just to detect images, which is fun for me to use, but to take decisions that have impact on our own life. I mean, should I get the credit or not?
Absolutely.
Should I be allowed to do this or that or not? And so, for example, in France, we have a law that has been recently passed that requires this algorithm to be fair, which is something which is very difficult to do, but at least to explain why this particular result has been obtained. If you look at your example with dog versus ostrich, so I would like to know why one is ostrich and the other dog, imagining that instead of ostrich on dog is I get my credit for my house or not.
Right.
So can you comment on the technology and research in doing this area?
So I have several things to say about this. One is that there are machine learning techniques to force a machine learning decision-making system to be insensitive to some variables. So in other words, we can train a system so that it will learn to ignore even implicit information about things like gender or race or whatever variable that is measured. You need to have those variables being measured. And then we can train the system so that somehow not only it doesn't take these variables into account explicitly, but it doesn't use information that's implicitly in the other variables in order to exploit the gender or the race. So that's one thing. And that's the kind of thing that governments could enforce on companies, and otherwise companies might not do it because that's going to decrease the accuracy of those systems. Right? So if you're an insurance company, you want maximum accuracy because that translates directly into dollars. But ethics, doesn't show on the balance sheet, not immediately. So the other thing is about explaining those systems. Well, unfortunately, AI systems by nature are complex. They involve, huge numbers of numbers, and it's hard to get a complete explanation. But you can get some explanation. You can get, for example, an explanation about how the system was trained to make sure that it's fair and it's using representative data and things like this. You can get an explanation for a particular case about which of the variables were used for this case, and you really make you go from yes to no, and you can do more sophisticated things to try to look inside and sort of come up with what were the more abstract elements, and there are all kinds of visualizations that exist. And eventually we'll be building systems that can provide a natural language explanation. But we have to keep in mind it's just like a human, right? So when a human takes a decision, it's hard to really know why they took that decision. We can ask, why did you do that? And they will say something, but it's not the complete explanation. So the same thing will be true for AI systems in the future.
Okay, thanks a lot.
Thank you for that. And will you be around during the coffee break? No, so we can't continue the conversation. That's too bad. Anyway, I would like to thank you once again for your presentation and also the other speakers. And I think we are now going to do a little bit of changing on the stage because we go over to our panel. So I would like to invite the panel people up. And the panel will be moderated by Leslie McIntosh, who is our brand new RDA US Director.
So we have no slides, so we'll go. We have no slides, so for you. Yes. Okay, thank you. I'll do this one. Sure. Okay, sure. Just let me see okay.
Okay, welcome, and thank you so much. Thank you for that wonderful talk once again. That was a fantastic keynote. And I think it ties right into what we're about to go into, which is a panel on data policy. And this will be a little bit shorter, so we're going to do 30 minutes, and we're going to have introductions and really go through 2 questions before we get to questions from the audience. So sort of the speed dating of data policy is what we're about to have with our wonderful panelists. So as Ingrid mentioned, I'm Leslie McIntosh Borelli, and I am the new Executive Director for the RDA US, and I'm very excited to be here. And with that, the RDA Secretariat has put together a wonderful panel, and they each will introduce themselves and make sure the microphone works, right?
Is this working?
Not yet.
There we go. It helps to turn it on. So my name is Matthew Lucas. I'm the Executive Director of Corporate Strategy and Performance at the Social Sciences and Humanities Research Council of Canada, otherwise known as SSHRC. And I'm actually here replacing our Executive Vice President, Brent Herbert Copley, who unfortunately at the last minute was unable to make it. But I would like to just say he and our President, Ted Hewitt, have been very enthusiastic supporters of RDA, are thrilled that RDA could come to Montreal. And I would also just like to pass on their thanks to the organizers, Université de Montréal, Research Data Canada, and of course, Research Data Alliance for making this a reality.
Hello, I'm David Carr. I'm a Program Manager for Open Research at the Wellcome Trust. For those of you who don't know, welcome. We're a global charitable research foundation dedicated to improving health for all through supporting biomedical research and a range of related activities. We've been a long-standing kind of champion and advocate for openness for, well, more than 2 decades, and I'm part of a new sort of small internal team at Wellcome, which is sort of driving forward our work around openness and building on our support for open access and data sharing. And likewise, thrilled to be here and have the opportunity to speak to you. Thanks.
So I'm Shelley Stahl. I'm the Director of Data Programs for the American Geophysical Union. We have over 60,000 members worldwide across 144 countries. And we also are a publishing house. We've got 20 peer-reviewed journals with 4 Gold Open standard.
Thank you very much. I'm Simon Hodson, Executive Director of CODATA. CODATA is the Committee on Data of the International Council of Science. We have 3 strategic priority areas of activity. We do a lot of work on data policies, which I guess is why I'm on the panel, and we have an International Data Policy Committee, which has been newly reformed under the chairmanship of Paul Uller, and there's a number of members of that committee here in this room. We do work on what we call the frontiers of data science, in particular standards and interoperability. We do a lot of work on capacity building as well. Thank you very much.
Thank you all for being here. So our first question that each of them will answer, it's the same question for each of them, is what is a significant recent policy impacting data management, and why is this significant?
Okay. I neglected to mention why I'm on the panel today, and it is because on behalf of all of the federal granting agencies of Canada, SSHRC is presently developing a harmonized policy around research data management, building on a statement of principles we published about 2 years ago, which laid out our aspirational goals and objectives for how researchers would manage their data and the responsibilities we saw of different players in the ecosystem, the responsibilities of institutions, the responsibilities of researchers, the responsibilities of disciplinary associations, and of course the responsibilities of funders. So I'll very quickly run through some of the key elements of our proposed policy. We're still in a consultation phase, and I would be happy to discuss it in any more detail with those that would wish afterwards. So there are 3 elements we believe would be part of this policy. One would be a requirement for institutions, universities and colleges to have institutional strategies for how they support research data management or how they support their researchers' research data management needs. And we would require that those strategies be public. Second, the requirement for data management plans for researchers that do receive federal funding. The one slight difference in how we would propose to approach this, at least at the beginning, is that rather than use those plans in adjudication, those plans would be submitted to the researchers' institutions, and the institutions would need to verify that they had been submitted before research funds could flow to the individual researchers. We would, at the granting agencies, retain the right to see those plans, and for certain funding opportunities, of course, we could include those in the adjudication process. A final requirement would be around data deposits, that researchers deposit their data that is directly related to the formal research outputs, primarily research articles, and that would be our third deposit. The potential plan for implementing this would involve sort of a gradual implementation, seeing the institutional strategies as the first piece that would be required, followed by data management plans and data deposits. I just want to take my last 30 seconds to talk a little bit about our approach to this, because in developing this policy and in talking to researchers and institutions across the country, it's clear that how we approach this is extremely important. So one, we recognize one size does not fit all. We recognize that while we have certain standards around data management, what data means, what proper research, what proper management means, what sharing means, differs according to certain research communities, and we need them to work with us to help define that. Secondly, and stemming directly from that, working together is crucial. We and the funding agencies are one of a number of partners that need to be working together to define all of these things, and it's been interesting in our consultations because we've been speaking to disciplinary associations, encouraging them to get much more involved in this process. We've also been bringing together different parts of the universities. For example, we had some consultations in which we brought CIOs, ethics people, research service people, and librarians together in a room from a number of universities to talk about what research data meant for those different players. And aside from the interesting fact that some of them from the same institutions had actually never met before, it was a fascinating conversation to have the ethics person sit down with the CIO talking about security issues. So it's been fascinating bringing that across. And finally, when it comes to, we are often asked, what's the incentive? Because cultural change, which this involves, is driven by incentives. And from our perspective, the best incentive is simply this is good research. At the end of the day, this is about good methodology. Researchers that are using data need to be able to manage that data and explain how they use that data properly. And at the end of the day, data management is just about research excellence. And those researchers that aren't managing their data properly are going to find themselves left behind in this. Happy to add any other comments later, but I'll now pass it on to my co-panelists.
Thank you.
Excellent. So I'm also coming from a funder perspective, but from the perspective of a funder who's had kind of policies supporting data sharing in place for a while. And probably the biggest sort of change that we've done through at Wellcome in the last couple of months in terms of our policy is that we, in July, expanded our previous data management and sharing policy, which had been in place for around 10 years, into a sort of much broader policy around managing and sharing data, software, and materials. And our reason for doing this was really to encourage researchers to take a sort of more holistic view of their research outputs and consider sort of data alongside other types of valuable outputs and how they would maximize and how they were going to sort of maximize the value of those outputs as a whole. So rather than require a data management and sharing plan on its own going forward, Wellcome is going to require a broader outputs management sharing plan. We also use the opportunity in updating our policy to sort of really sort of try to clarify some of our expectations and requirements slightly more clearly. And probably the sort of most significant one of those is to really sort of bring up front and center our sort of key requirement that data and original software underlying publications must be made available to other researchers at the point of publication. We also going to use the opportunity to try to develop a more systematic approach to tracking the extent to which researchers put their plans into practice, including a formal kind of check at the sort of end of grant reporting stage. I think Wellcome's sort of development of our policy is kind of indicative of a sort of a broader trend amongst funders, which has been happening for a number of years to try to sort of strengthen their policies and expectations around sharing data and other research outputs, and increasingly, as my colleague said, to work in partnership both sort of amongst funders internationally, but also with the broader research community to really try to maximize the value of data and other outputs and support reproducibility. So there's a number of key challenges which I wanted to highlight that I think we're increasingly working together to try to address. I think there's a question, again, as my colleague mentioned, around how we can better incentivize data sharing through developments to our sort of policies and practices as funders. A key challenge around sort of how we fund and sustain key data resources, how we might work together to support innovation in data sharing and open research more broadly. And I think a critical final point, how we can sort of work together to sort of evaluate and build the evidence base around the benefits of openness. Because certainly in my organisation, and I'm sure a lot of other funders too, we really have to sort of produce the sort of evidence that our sort of investment in this activity is really sort of enhancing research and its application. And so those are some of the sort of the really key challenges that that we're sort of working together to try to overcome.
Thank you, David. Shelley.
Thank you. So within the journal community, there's a guideline that was put together funded by the Arnold Foundation through AAAS on a series of talks, gatherings on reproducibility. And that first meeting created the top guidelines. So this is transparency, openness, promotion, and AGU was part of developing those, and so the Center for Open Science and many others, perhaps others in this room. There are at this point, there's 2,900 journals and organizations that have signed on to these guidelines, and specific to data in the work of the RDA, citation standards, data transparency, putting that data into a proper repository that's trusted, and the analytical methods, meaning the code transparency, so the software that supports the data and the research. So these, and the big news actually is just last week Elsevier signed on. So we are really delighted to hear that they're moving forward with the rest of the journal community. At AGU, we want to be a leader in moving up the levels of implementation. So there are 4 levels of implementation within these guidelines, 0 through 3, and we are targeting hitting somewhere between 2 and 3. 3 is actually very difficult and may not apply to all of the Earth and space science data. So it depends a little bit on exactly what that data is. So what we've done is we are partnering actually with RDA. RDA is one of our partners, ESIP, Nature, Science, the Proceedings for the National Academies, ANS, NCI, and OSCOPE are all, and the Center for Open Science, are all partners with us on a grant that we just received from the Arnold Foundation to take the Earth and space science community, all of the journals, not just AGU, but all of the journals, such that whenever an author publishes within that community, data has to be with the paper. And I'm not saying the data goes into the data supplement where it will never be found again. I'm saying the data goes into a proper repository where it has a DOI and it can be cited within the paper. So the trajectory here is about 18 months before we start to have initial implementation, and we have quite a lot of work to do. It's really important that I explain that this is a community effort. AGU will convene this, will help facilitate this. The community will own the guidelines when we step back. Well, we can't own this. This is across the entire space for Earth and space science. So we're leaning heavily on RDA and the groups that have been identified here that can support that, and all of the other communities that are working on the standards that are going to be necessary for this. One of the more challenging ones, and if during this week, if you see me and you can help guide on this, we are trying to identify the difference between what level of metadata is necessary. We have discovery needs, we have accessibility needs, and then we also want to make sure that that data can be well understood, if there's no one else to answer questions on it. So down to the data type, domain level, and then how much, and then how can we make that understanding by data type available to anyone. Think cross transdisciplinary science, think folks that may not know what a community standard is or know where to go. How can we make it easier? And I believe there's been an awful lot of work done at RDA already to those standards.
Thank you. Simon.
Thank you. Excuse me, I should have mentioned when I introduced myself that I'm also chairing the European Commission's expert group on fair data and putting fair data into practice. So I wanted to really talk about that a little bit, and we were asked to indicate sort of what we think from a policy perspective is coming along that's a game changer, or that RDA and other organizations need to respond to. And so I would say that the FAIR principles have had a transformative effect over the last 2 years since they've been around. They didn't come out of nowhere. They have long antecedents, and you can look at various clusters of attributes that are necessary for data to be reusable and understandable in reports that go back at least, if not further, to the OECD principles on the public access to data produced by publicly funded research. However, I think we have to recognize that FAIR caught the zeitgeist, and we also have to recognize when form is just as important as content, and the rhetoric value and effect of FAIR, that nice little acronym which communicates something very important but in a snappy and easy way. The data should be findable, accessible, interoperable and reusable. That has really worked. And one does feel that it's caught the attention of certain research communities and in particular of the funders. We hear a lot about FAIR, we hear a lot about groups trying to identify metrics to determine whether data sets and activities are fair. And so in a fit of dreadful, in a fit of overbearing optimism, I do think that this acronym has very much helped this community that's working on research data and working on the value and the reusability of research data. What that expert group is doing is trying to lay out a set of principles and guidelines, extrapolating from the FAIR principles, such that data produced by research funded by the European Commission can more easily comply with those attributes and those principles. It's essentially a set of guidelines to make FAIR data a reality. That's the strap line. Unlike some of the groups that are looking at FAIR metrics, we're taking, I think, a more holistic approach, and the report, which will be produced in draft by early 2018 and published in March or April of 2018, will try to take a more holistic view, less a data-centric view than a view of what various stakeholders and actors need to do in order to realize the FAIR principles. In particular, there are certain areas which need expansion. Clear guidelines has already been mentioned of what's required in terms of metadata for data to be fully interoperable and reusable, and augmenting the existing FAIR principles with at least some statement on the necessity of long-term stewardship and responsibility will also be an important area. We also want to address research culture, but I think that's something that I'll come on to in the second part of the panel.
Thank you. Actually, what Shelley and Simon just brought up leads us very nicely into the second question, which is, how does each of these policies, or in particular what you were speaking of, affect RDA? And also, what can RDA do to affect or inform those policies?
So on a very simple level, I hope that the development of more coherent tri-agency policies in Canada will lead to a greater participation of Canadians in RDA events. I would also like to reflect, this is now my third plenary that I've attended, and when I think about why I appreciate coming to this event, there's a variety of reasons. One, the diversity of the groups represented here. Two, the kind of bottom-up approach. Of course, the more you put in, the more you get out, but it really lends itself to a variety of interests and a variety of useful outputs. And finally, of course, the international nature, as research knows no boundaries. The questions of metadata, the questions of how to implement FAIR principles are the same challenges are faced by all of us. And so, of course, through the various birds of a feather, and I'll put a little plug in here, we have a birds of a feather following this session that some colleagues of mine have created around data management policy and open data policies. So if you're interested, please come out. But those can be a very useful venue for communities to come together to have the conversation that, at least within Canada, some of those communities are not having. So when I've spoken to different disciplines, I've been encouraging them to look for opportunities to bring their members together to discuss what standards, as I mentioned earlier, of sharing and management are the standards of good practice within their communities. And of course, those standards will evolve, and we hope they will evolve, but this could provide a fabulous venue for those conversations to take place with international colleagues as well. Secondly, as a funder, I've benefited greatly from the opportunity to talk to other funders about the challenges they've faced in the policy sphere. Often when we're talking at the 50,000 foot, everything looks rather rosy, but when you start to dive down to say, so what is the quality of the data management plans you're actually receiving, and what are you doing about that, and what are the training challenges you're having, and what tools have you put in place? The conversations get very interesting, and we can certainly benefit from sharing the tools and knowledge with each other. So that as well, I think, is an area that we can benefit, and a role that RDA can continue to play for us. Thank you.
Thank you.
Okay, so I would definitely echo a lot of the things around the benefits of RDA as a forum for discussing some of the challenges I mentioned. Indeed, I think there's a huge amount of really sort of relevant and valuable work going across the various RDA groups in terms of the issues we face implementing our policies as funders. Just some examples around how we can develop consistent approaches for citing and tracking the usage of data and the value that comes out of it, how we can make data management plans that we require as funders more valuable and potentially machine actionable, and how we can develop standards for data repositories and work towards models for sustainability. So I think there's a huge amount of valuable stuff there. From a personal perspective, as a funder who's engaged a bit with RDA, I personally don't quite think the links between the sort of discussions we're having between funders and the work that happens within the RDA are quite there yet, or necessarily the emerging sort of outputs and recommendations from the RDA discussions are always sort of feeding through into our discussions as funders. So I think that's something that both sides need to work on a little more. And so I perhaps suggest RDA groups sort of really thinking about engagement with funders at the appropriate time and sort of building links to feed through their recommendations. And also from the funder side, certainly something that I'm very keen to do is to actively sort of look what's happening across RDA and how we can best sort of build on and engage with RDA better. But I think that's a conversation that needs to happen further. And then quite a specific point in closing I make just around sort of specific change in welcomes policy that I mentioned is sort of the extent to which RDA sort of addresses the links between data and other types of valuable outputs of research, particularly code and materials, as well as literature outputs. And so really sort of thinking about the extent to which sort of RDA is sort of tackling those big questions about how you need those outputs to be sort of shared and made available in a manner that enables reproducibility and maximizes value. Thank you.
Thank you. Shelley.
So for our proposal to the Arnold Foundation, it was really important that we partnered with international communities that understood what it meant to manage data. RDA was obviously the clear choice here, and that's why the intention is to leverage the work that you are doing. And we're just beginning those conversations. So if you haven't heard anything in your groups and you think that what you're doing matters to what I'm saying, be assured that the time is still there and you're not missing out on anything. There will be some more information that comes out, and certainly this week we can have conversations. Okay, so in specific. So in order to make a solution work across journals connecting to repositories, so we're talking about all the repositories. We're not talking about picking our favorite and using that. When we're talking about every repository that holds Earth and space science as being part of this community. And we want to help to direct researchers to find these repositories that they typically, data that they collect, data that they use, and they know how to find. So we need good mechanisms for identifying and directing researchers to repositories. We also need to have common understandings on what the basic criteria is for a repository that's holding data. What are the preservation requirements? We have some fantastic certifications, DSA, WDS, the requirements that Data One has put out, the new one, Core, I'm looking at Ingrid, Core Trust. Core Trust Seal, yes, and I'm catching up on that one, as you can see. But that one also is really important. So what we're hoping is that we can say, okay, if you have one of these certifications, you're good to go as a repository that supports persistent identifiers, has a landing page, supports data citation, takes care of the metadata at the requirements that we're looking for, and you're preserving that data into time. I'm not quite sure what that means exactly, but those are the base criteria. Now, if you're a repository that hasn't done that, you might want to consider it, but make sure that you're meeting these criteria so that we can have journals recommending and endorsing these repositories as something that can be used. So you can see there's a lot of connection between what the journal community is trying to do, and our project is called Enabling Fair Data, just so yeah, okay, just I'm going to make sure Simon knows there's the love there. Okay, I think that might be good. So.
And then in our last couple of minutes, Simon.
Thanks. I wanted to highlight two issues, one to do with research culture, one to do with the global dimensions of this. In terms of research culture, I do find it, and I suspect many people in this room find it depressing sometimes that a lot of the emphasis seems to be on compliance, what researchers and institutions have to do to meet certain criteria, etc. And that can make the whole exercise seem tawdry, depressing, and it's to miss the real importance of the message, why we're doing this. I very much enjoyed our keynote this morning in many respects, but in particular because there was a very clear message there that interoperability, consistency in the description of particular data is essential for AI to achieve its potential. We need to hear more about what Christine Borgman says, no data, the lack of data for particular research projects, and the difficulty in using data at scale. One of the things that I think is very interesting about the FAIR principles is it did come very much out of a community that was interested in reproducibility and what can be done when data is genuinely interoperable, and that's to do with analysis at scale. A lot of it came out of the bioinformatics community. So data that can be reused, understanding that in a sense researchers and research institutions should be viewing this less from a compliance point of view, what do we have to do because the funder says so, but what do we need to do in order that we can have access to the data that we need to do our research? So that's one little rant, apologies for that. The other one is the global dimension. So FAIR is a nice slogan, it's a nice acronym. A nice acronym. We don't want it to be an anachronism. No, it should also mean equitable. It is, CoData does a lot of work in the Global South, and we have a South African government-funded African Open Science Platform project, and I know that the RDA as well is very interested in being genuinely a global organization. It's important for us that we should be global and not just North Atlantic. And to that end, it's important that data should be fair in terms of equity as well. And it's very important that when research is done in the Global South, that those data should be available to researchers in the Global South. Open data is one way of achieving that, but there's important messages and communication that needs to be done, and action, to make sure that open data isn't viewed, in reality or otherwise, as another form of extraction. There's been too much of that.
And we're at time, if we can think that that's a great point to end on. I think we obviously don't have enough time for questions, but everyone's going to be here during the conference, I think available during coffee, and we don't want to keep people from coffee anymore. So let's thank our panelists once again for these wonderful points.
And thank you, Leslie, for moderating the panel. Before everyone leaves for the coffee break, one tiny housekeeping announcement. A number of sessions has been cancelled, and that means that your nice little booklet is not completely up to date anymore. So please, before you go to any of the breakout sessions, check the online version of the program. And enjoy your coffee. You've deserved it.